Hello, and welcome to the Sleep Science Podcast. I'm Penny Lewis, a neuroscientist specializing in sleep and memory, and the presenter of this show. In the podcast, we talk about all things related to sleep, from dreaming and sleepwalking to what sleep does for our brain and body, and how we can get more out of our sleep. Today, we're going to talk about the mystery of why and how stage 1 sleep boosts creativity. This is one of the newest and most surprising areas of sleep research, and with us today are 4 of the most important researchers in this field. Firstly, Professor Bob Stickgold of Harvard University, currently a visiting professor at MIT's Media Lab, is an internationally renowned expert on dreaming and memory, and a key player in bringing the science of sleep and memory to the forefront of research over the last 25 years. And working closely with Professor Stickgold, Dr. Adam Horowitz, formerly of the MIT Media Lab, but now at Outer Coast College, has developed a special device called the Dormio Glove, which facilitates the use of N1 sleep to access creativity. And then from the other side of the Atlantic, Dr. Delphine Oudiette, who co-leads the DREAM team at the Paris Brain Institute, and who has done a lot of work on sleep and memory and dreams, including several very interesting studies on N1 sleep and creativity, which we're going to talk about, and Dr. Celia Lacaux, who worked with Delphine previously and is now a postdoctoral researcher at the University of Geneva Department of Neurosciences, and was responsible for the most striking study finding the importance of N1 sleep for creativity. It's a real privilege to have you all here, and welcome to the show. I'd like to kick off by describing the phenomena of what N1 sleep is doing for creativity, because I'm guessing most of our audience won't be familiar with this. And I think probably the most appropriate person for this is Celia. Would you mind explaining the phenomena and then telling us what you did to study this?
Yes, of course. So first I have to say that it's a bit by serendipity that we discovered that, because initially we were interested in REM sleep and not on sleep onset at all, to be honest. And so it's when we were actually piloting an experiment on REM sleep and problem solving that I actually noticed that some participants were reporting that when they were falling asleep, they were seeing the games, and then they actually were discovering a hidden rule within the game during sleep onset. And so actually then we thought with Delphine, well, actually, that could make sense because REM sleep and N1 share similarity, both like phenomenologically, but also in terms of electrophysiological changes. And also we had all these anecdotes from scientists and artists who said that they were actually making some discoveries during sleep onset. So especially Thomas Edison, for example, but also Salvador Dali. And so we actually based this experiment that we ran on this kind of anecdote of Thomas Edison that developed a technique to basically capture this moment, because we have to know that sleep onset is super quick. It's a fleeting moment that lasts only a few minutes, and then you go into deeper sleep. So you need to capture that specific moment before going into deeper sleep. So that was the point of this technique. So basically he used to take naps, but in very peculiar conditions. So he used to sit in an armchair, and then he was holding one object in his hand. So it was here a metal sphere, but with Dali it was a key, can be anything. And so the idea is that when you're falling asleep, you have a muscle relaxation, and then the object actually drops, and the sun is actually awakening you just in time to basically capture this sleep onset moment and the creative inspiration. And so we basically based the experiment on that. And so we reused the exact same protocol, and we also reused a well-known task in the literature that is known as the number reduction task. So it's basically you show arithmetical problems to participants, and it's quite easy to solve. You have a lot of them and you give them a way of solving them, but it's actually very long and very fastidious. So solving each of these problems takes actually a lot of time, and they have a lot of them to solve. And what we don't tell them is that there is actually a sort of hidden rule within each of these sequences that allows solving them much faster, but they don't know. And so they are actually doing a lot of them before and after a 20-minute nap in those Edison's Dali condition. And then we were just looking at what happened after the nap, depending on what happened during the nap.
So this sounds like a really interesting experiment, and it's great that it's based on historical activity that Edison was doing in this way, and that you decided to then go after this scientifically with kind of a contemporary task. What did you actually find?
First, we had some participants who actually discovered this hidden rule before the break. So this participant, we didn't look at them because they were too smart for us. Then we looked at the remaining ones. And among the remaining ones, what we observed is that the one who actually went into N1, so this sleep onset period, just solely on average 1 minute spent in that period was sufficient to almost triple the probability of finding afterwards the hidden rule compared to either participant who remained awake during the same period of time or participants who actually went into deeper sleep into N2.
So the participants who went into stage 1 sleep had a benefit, but the ones who then also moved into N2 additionally did not have a benefit. Is that right?
So either who actually went into N1 and then into N2. Also, we also had some participants who actually directly went into N2 because they were also a bit sleep deprived. They had like too much sleep pressure, and so they actually didn't go through N1 and they directly entered N2.
And what did this benefit look like for the N1 people?
It was just a drastic reduction in solving time because then they discovered this kind of a shortcut. And also it was accompanied by a sort of eureka. So afterwards, during the debrief, I was like, okay, but so you found that, but how did it come up? And do you remember? And they just said, I don't know, at some point at this block, I just realized, but they weren't able to really describe how this kind of insight arrived, which is in the definition of insight and eureka. You're not able to actually retrace the mental step that led to this solution.
Bob Stickgold.
So Celia, I'm curious because if you read about Edison or about Salvador Dali, they say that as soon as they woke up, they had the answer.
Sure.
Dali in his writing says it takes a quarter second. You have to be asleep for the time it takes that ball to drop from my hand to a tin plate on the floor, and then I have the inspiration. But that doesn't happen with the number reduction task, right? They do a half dozen or dozen trials.
Even 1 hour, it takes ages, actually. There was like 1 hour before they had this eureka, which was surprising because indeed it's not the same compared to all of these anecdotes.
Adam Horowitz.
It seems also particularly different in terms of the kind of creativity we're talking about. One of the main differences, I mean, I'm interested in all of your work is, it seems like Dali can find his solution in the phenomenology of the dream. He can say, oh, I had this dream and there were these stretching creatures and the stretching creatures are the thing that I want to paint, and that's great. I've seen it in the dream. And I don't know what a faster solution to the number reduction task would look like in a dream in particular. And so I'm curious if these are maybe different kinds of creativity and we're using the same word to refer to something like a surrealist painting and something like a mathematical solution.
And Celia, your subjects didn't go down for their nap wanting to find a solution, looking for a shortcut. They didn't even know that a shortcut existed.
No, they didn't know. And we really asked at the very end, like you really didn't guess anything. And even we had some participant at the very end who told us, I had some of an intuition during the pre-phase, and this subject we actually removed them to make sure that really we had only participants who didn't know at all that there was something to find.
And what do you two think it would look like if you said you might find a solution in your dreams?
Well, that's a question I had and maybe actually wouldn't work. I have the feeling that all of this implicit are working better. Also, like, for example, from the Sarah Megnick one with the remote associated task. Like here, it was the answer that were in the analogy task that were actually reused and had an effect with REM sleep. But then this is again kind of implicit because they don't know that this answer on the analogy task were important after sleep.
So I think this might be a good time to ask something important which we haven't defined yet, but can someone explain what N1 sleep actually is? What is stage 1 sleep?
You know, back in either 94 or 95, I went to a conference on sleep onset. And when I came home, I told people that what everybody at the conference seemed to be saying is there is no moment of sleep onset, and I can measure it better than you can. So it's like, it's a murky, murky time. And everybody who sleeps knows this. You know, you're sort of falling asleep, you're asleep, maybe you're not asleep. It's defined by electrophysiological, by EEG changes. And it's just the period of time that you're falling asleep. You start to lose awareness of the outside world. Your eyes actually start to roll back and forth. Your EEG slows down. One professor, Huri, actually came up with 9 stages of sleep onset, so you can dice it up very small. But it's really just this period of a couple minutes, 3-4 minutes, where the brain shifts from full wakefulness to full sleep.
I think for listeners, it's also important. It's that moment when you're watching TV in your armchair and you just start drifting off and, whoa, did I even fall asleep? And then it turns out, for a lot of folks, when I talk about N1, they say, oh yeah, well that's when I have my craziest dreams because that TV show, it entered my dream. So I think one of the reasons that Bob did his Tetris paper originally is this kind of correspondence between N1 experience and daytime experience.
And this is hypnagogia, isn't it? So these are the dreams that happen at sleep onset. And I think the point that you're making here is just that, there are so many dreams at that point, and they relate to what you were thinking about or working on soon before you went to sleep.
Yeah, and it doesn't have to be soon. It can be a couple of hours before even, just so long as it was impactful enough when you do it so that it comes back.
Delphine, Oudiette.
Maybe I can jump into just for the listeners who are worried that they don't have this kind of images. I think we have this fascination in common with Bob and Adam, where we see a lot of stuff when we fall asleep, but actually not everyone. When we made a poll in the lab, and I had a hard time to try to describe the experience that I have when I close my eyes and fall asleep. And I feel that some people maybe don't see images, but it's like illogical thoughts, or just lose consciousness altogether. And their boyfriend or girlfriend say, oh, but you were snoring all the time. And that's how they know that they fell asleep. And so if you ask people in a room, I feel half of the population will say, I know completely what you mean. That's crazy. That's like the richer dream-like experience that I have. And other look at you really weirdly and say, like, what do you mean? Like, you see stuff that don't exist. I don't see the point. Right now in the lab, we're trying to study the diversity of mental experiences that we can have in the borderland of sleep. And we see that there is a lot of diverse possibilities.
We did a study back in the 90s again, just with Harvard undergraduates, and half of the subjects we enrolled said, I have no idea what you're talking about. It's exactly what Delphine is saying. But then when we did the experiment and woke them up, they said, oh my God, I was having this weird little dream. So I think the people who don't know that they do it are people who fall asleep fast, because you really only know about it if you float in that zone. But, if you just put your head down on the pillow and wham, you're out. You still have those sleep onset images, but you just don't remember them.
No, I completely agree. But it could be interesting, I think, to study this phenomenology, to give an insight of the trajectory of everybody's sleeping patterns, and could be potentially connected to the feeling that some people experience. Some kind of insomnia, maybe, could be linked to kind of poor dream-like content or thought-like contents that could make them feel that they are awake for a longest time. So it's one of the axes that could be interesting to dig in the future, I think.
I have also had the experience of people coming into the lab and saying, I didn't really know what this was for. I know it was a sleep thing, but I don't dream, so I'll be a really bad subject. And I said, oh, no problem. Just because recall from hypnagogia is so high. And I think so many people will fall asleep, fall through hypnagogia, and then have 8 hours of sleep, and then wake up really quickly to an alarm, and then go to work, and then forget their dream content. And of course, and for those folks, I have not had people come in and go through the serial awakenings paradigm and give me nothing. And I think there's 2 reasons. I think one of the reasons is about the sleep interruption. I think the other is about widening the definition of what a dream is. And so I'm interested in anything that is mentation in sleep. And that could be a fully immersive, fractal, whatever, REM dream. Or it could be what Bob said. It could be a thought path that takes a strange walk. It could be something like future planning, just when it looks like on EEG somebody's asleep, but they're thinking about something which is pretty mundane. And so I think 2 things for listeners, maybe just to Delphine's point, who think, oh, it would be so cool if I dreamt. Maybe there are some fun experiments to play, setting a few alarms in a row, and you might find that you are dreaming.
The serial awakenings task involves waking people up again and again and asking what they were thinking about. It's used to study their dreams.
Delphine, you had said you were interested in doing a study to look at the range of phenomenology that we see at this time. And I've been struck by the fact that if you go back to the really early literature, people talk about geometric shapes being seen at sleep onset. I've collected hundreds and hundreds of sleep onset reports and have never gotten a report of someone seeing geometric shapes. So first, I'm curious whether anybody else in this group has gotten those reports. And second, if not, what is different about now than 100 years ago?
Okay, so first I do personally see geometric shapes.
Oh, thank you. Thank you.
And in Celia's study, we got one guy who saw the, how do you say in English? The
screensavers.
Yeah, that looks like a pattern of shape that goes back and change the size, like the old screensaver in the old computer back in the days. So like we are running a study, like just a questionnaire. So we have two parts. One is a big questionnaire that we'll send to thousands of people, hopefully across different cultures, to see if there's like common patterns of mental experiences during sleep onsets across everybody. And if we have some peculiar type of experiences in different cultures, for example. And the other side is to try to define. So, for example, Adam, you say that you take everything, like the crazy immersive experiences, but also change in train thoughts. And that, I think, might be linked to different patterns in the EEG activity, because in N1, you have some parts of like mini boots of wakefulness, mini boots of sleep. So we don't really know in that particular stages if we collect dream as something happening during sleep or some really short wake experiences happening during these little boots of wakefulness inside the epoch. And so we ask 100 participants to have naps in the lab. We wake them up at different moments, and then we ask them what went through their mind at that very moment, but also to rate their mental experience across different subjective dimensions. Do they see something? Is that bizarre? Is that spontaneous? Can they control the pattern or not? And so we have these different dimensions, and then we use some algorithm to cluster the different mental states that we call in an agnostic way. So without trying to impose a definition, but we let the data speak for themselves. And what we found is 4 different clusters that could happen actually in all sleep stages that we have collected. So wakefulness, N1 and N2. But with variable proportions. And our different clusters, we have one that corresponds to what we imagine when we talk about hypnagogia. So it's bizarre, highly perceptual. People feel a little bit more sleepy and very spontaneous. They can't control the content. And we have 3 other clusters that are more like thinking, but some are kind of related to memory, like the past. Some are really close to the present moment, so I can hear noises in my background. And some are planification of the future, if I like really do a general caricature of the results. And so that's cool because we have these different clusters that could happen to in any stages, and we could have some EEG signatures of these different stages. So that's like a new result that is not published yet. But
just to start with, it's already confusing because like a lot of people actually think that they are awake and report crazy stuff and vice versa. So it's already confusing. So at least let's go a bit like more into the complexity of it. And especially more consider like all of this local sleep, new paper and new research area, and think, okay, so maybe like all of these different phenomenological and mental contents that we're having depends maybe on local different intensities, let's say, of local sleep, and especially where it happens in the brain. So that could also explain, depending on which actually brain areas are locally asleep, then you can predict different mental content. And then it actually makes more sense than just say, oh, like here I see theta and here I see alpha, and then the person is awake or asleep, but actually no, if you actually go a bit deeper into their mental content, it's not explaining everything. So it means that in a way, it's not completely right, like this classification of, doing the sleep and wake stages.
I think we've had a really nice discussion about what stage 1 or N1 sleep is, and some of the reasons why we might think that that was related to creativity. But for me, I think there were so many reasons that I'm almost getting a little bit lost. So could somebody maybe briefly recap? Maybe Adam, can you recap the reasons that you would say you felt that this might be important for creativity and you got interested in stage 1 sleep?
The first step in the kind of train of logic is saying something like, well, dreams in general might matter for waking thought. And for a lot of people, even that first premise is ridiculous. Dreams are too weird and I forget them anyways, so how could they influence my waking thinking? But then there's a couple papers which show correlations between your dream content and then your sleep-dependent memory processing. So I'm thinking about papers on foreign language learning. If you dream in a foreign language earlier in a language learning course, then you're going to do better at the end of that course. Or others on dreaming about a story and remembering story content, word picture associations, visuospatial memories. There's a few. But for me, at least, that was asking a different question. That was saying, oh, if something comes up in a dream, maybe that dream reflects some memory processing that's happening. But the dream itself is kind of just a reflection, what people call an epiphenomenon. And I got really excited, and when I read Bob's Tetris paper, I got even more excited about saying, no, what if the dream is the important thing? Maybe it's not reflecting some sleep-dependent memory processing. Maybe it itself is useful. And then, what Delphine and Celia were talking about earlier, and then you read somebody like Kekulé on benzene. They didn't just have some sort of reflection of processing. They said, no, in my dream, I saw a snake eating its own tail, and that made me understand the chemical formulation of benzene. And the first step for me was dreams matter for changing waking cognition. And the second step was saying the dream content matters, not just the dream as a reflection of ongoing processing in the brain. And then the third step is, well, what could dreams matter for? And everyone I talk to, the big thing is creativity. As, oh, I use my dreams to write my poems. It's just everywhere. It's in the air. And yet there's no studies on it over the past 100 years. It's totally weird. There's only correlational studies. There's Deirdre Barrett's work showing that people use their dreams in creative problem solving. There's, again, all of this anecdotal work, but there aren't really studies which show you can intervene on a dream and then change creative processing. And so I think your sweet spot paper is awesome because it really validates that you can intervene in terms of sleep staging and interrupting sleep at the right moment to increase creativity. And then I think what Bob and I tried to do with the Dormio work was saying, if we push a little further, yes, we can intervene and make people remember more of their N1 content, but then we can maybe guide their N1 dream content towards a certain topic. And then we get to ask, well, if we guide it towards a topic and they dream about that thing, then are they more creative than people who don't dream about that thing? And so there's many steps, but at the end, that's where I ended up saying, oh, that's why this might be a cool thing to ask about.
Okay, so we've got this sleep stage. It's the transition from wake to sleep. There's all this anecdotal evidence suggesting that it's important for creativity from Edison, from Dali. Then there's all this evidence about people dreaming from the Tetris study, also from people's just subjective reports that we're hearing, lots of dreaming going on. And then Adam has just made the link between dreaming and creativity. So those are kind of some connections that I see coming out. But could we maybe think together about, is it just the fact that dreaming is happening in this sleep state? What is it that's happening in stage 1 sleep that would facilitate dreaming and creativity?
My favorite person on sleep onset is Mavromatis, who wrote a 300-page thesis on it, which is honestly worth reading. And he talks a lot about sleep onset being a space where you can let your mind wander while watching it wander. It has this kind of transient metacognition. And in the daytime, it's often really hard to let yourself wander beyond the obvious possibilities. And in something like REM sleep, we've left all the obvious possibilities behind and we're totally gone into the least obvious and most bizarre. And sleep onset is a little bit in between. You can wander and then grab something interesting because you're still awake enough to watch where your mind is wandering. And I like this creativity model, which says, this is in waking creativity and in sleep, which is called blind variation and selective retention. And it's this idea that to be really creative, you need to let your mind blindly vary, but then selectively process the good stuff. And so if you're too far gone and you're wandering and you don't have the capacity for retention, maybe it's less useful. If you're not able to wander enough, maybe it's less useful. And so I think sweet spot is the best word for it. It's this just sweet in between blind variation and metacognitive capacity.
Also, just to precise, maybe we need also to go back to creativity definition, because it's actually in the conventional definition of creativity that it has to be something original, new. So, okay, you have to explore, but at some point it also have to be coherent and pertinent and adapted to like a given context. So this is the, okay, exploration, but also then evaluation phase. That is actually inside the very definition of creativity. And I agree that then sleep onset seems to be the perfect phase for that. And if we go back to electrophysiology, this is, I think, also rooted to the fact that when we fall asleep, it's not like immediate, as we said, like this is very progressive, very gradual. And we have this antero to posterior gradient. So meaning that not all of your brain regions are falling asleep at once. But first, the frontal regions that actually are the one in general who actually constrain you. And then it goes to central and occipital regions. So that may allow you to have like these two components that are very important for creativity of like exploration and evaluation at the same time within the sleep onset period.
So Celia, that's super interesting. So what I think you're suggesting is that it's to do with which brain regions haven't been inactivated yet. If we think of the falling asleep as a kind of a progressive loss of consciousness in different brain regions, you're almost saying it's because some things remain conscious. Are you saying the frontal regions remain conscious and the
frontal regions are the first one to fall asleep after like thalamus and all this. First subcortical region, then frontal regions, and the last one are actually the occipital. And actually, even on EEG, if you look at it, we can observe it. So, for example, you can observe like theta activity before on the frontal electrodes before occipital ones. So even our way of scoring sleep stages, most of the time, I don't know for you, but me, I score on occipital ones, but it's actually kind of the last stage of sleep onset. And that might explain also differences again in your mental content during sleep onset, depending on where actually this delta activity and theta activity is reaching your different parts of your cortex. Well, then you might experience different type of mental content. And that might be the kind of ideal cocktail for you to be creative.
The frontal cortex is the region of your brain that puts limits on how far you're allowed to wander. And so when the frontal regions go off, you go into a much more bottom-up exploratory mode of thinking and of brain processing more generally.
Which region then is the one that's important for grabbing, for understanding what's important and what makes sense? Because I was wondering whether Celia might suggest then that it's the occipital regions that are important for that because they remain, they're the last ones essentially to lose consciousness. Or is that maybe just going too far and you wouldn't speculate that far? What do you think, Celia?
No, I think it's more your consciousness, like you being conscious of it. So for example, just as a personal example, I was using sleep offset that time. That is like another question that we had. Is it the same sleep onset and sleep offset? But for writing my PhD. So for example, when I was asking myself a question, what I did is basically to put a soft alarm and then I was just turning it off, but keeping my eyes closed and staying in that state. And then just was asking myself this question, okay, how can I explain this result? And then what I was observing is that I had a lot of different possibilities to explore. And I was, okay, that is interesting. But I was like semi-conscious. So basically I had far more creativity than like when I was awake, but still was able to kind of consciously be able to evaluate what was pertinent or not. And so this is really this in between for me. And so for me, at that point, it's more me being conscious of, this is cool. And I don't know which region is actually doing that at that point. So that's why I think that there are two actually important things about sleep onset and creativity. This is the state that your brain is in. And then there is something else that seems to happen during sleep onset, which is reprocessing of your memories that might actually lead also to insight about, there is a hidden regularity within these memories. But then for me, actually, the two are important and you can have like a combination of the two that is getting you massively creative. One, the brain state is important on one hand. and also what is going on in terms of memory reprocessing and dreams adds something in extra.
It's really awesome. And for listeners, I think there might be this idea that, a part of your brain turns off, and that sounds kind of like a bad thing. And so why would that help you do anything? And so often a comparison I will make is like, well, it's not surprising to you that Hemingway has to drink a bottle of whiskey to write a novel. And it's not surprising to you that there's this association between, drinking and drug use and making great songs and making great paintings. And, another thing that will decrease a lot of your frontal EEG activity is being drunk. And one of the ways people describe this state when you are in sleep offset and you're kind of, I'm a little drowsy and weird, is literally they call it sleep drunkenness. But that confusion or that kind of disorientation in the sense of getting you off of your normal oriented path can be really useful for creativity. And so just to make the link between decreased brain activity and increased performance, I think of it as a kind of drunkenness that lets you wander more widely because you don't have the same sort of capacity for surveillance of your own thoughts.
I want to ask two questions of people that I don't have an answer for. One is it really true that if you go into N2, you lose the creativity that occurred earlier, even though you don't experience the creativity until an hour after you wake up and have done many, many of these math problems? That's number one. And number two is, if this is such a powerful tool of human creativity, and I do believe it is, why is it only 2 or 3 minutes long? And why do some people hang in this state for 10 or 15 minutes as they're drifting in and out of sleep, and other people just whank down asleep and hit N2 almost immediately? I mean, it sounds like bad design.
So can I just jump in here and clarify for the listeners that what Bob is referring to here is the result from Celia and Delphine's sweet spot paper, where they found that people who experienced N1 had a subsequent benefit for their creativity. But if they moved from N1 into N2, so they had N1, stage 1 and stage 2 of non-REM sleep, or if they went straight into stage 2 sleep, that benefit was entirely removed. Why would that be the case?
Okay, so that's a great question for which we don't really have the answer, only hypothesis. First, in our design, we only have a short map of 20 minutes. So basically, the amount of N2 that you got is not like the normal amount that you would have if we didn't interrupt participants. So it's possible that our design kind of break the process that could have consolidated the creativity in N1, and then you have a consolidation of the memory of the rule, for example, in N2. And by interrupting it abruptly, we disturb that memory, and so it was lost. So that's one hypothesis that we have. The task that we use was used before in previous experiments for a night study when they had N1 but also N2, N3, and REM sleep and all the stages. And the benefits of a full night of sleep was kind of similar to ours, a bit lower, but I'm not sure if it's statistically significant. So if we compare the two studies, that means that in that case, N2 was not detrimental for creativity if you let people sleep the entire night. So it's possible that if you let an entire nap and just let people spontaneously emerge, that we will get the results. So I think in our paper, what I would emphasize is the striking effect of N1 that we try to isolate, to have a pure N1 separated from the following stages. But I'm not so sure about the generalizability of the N2 results, and we need to do more studies to see if the detrimental effect of N2 will hold in future work. Does it make sense?
It makes sense, and I think it's also important here that we clarify what N2 or stage 2 sleep actually is and how that differs from N1 sleep that we're talking about. I mean, for instance, maybe we could say at that stage, consciousness has been fully lost. Would that be fair to say? And the electrophysiology is different. Does someone want to maybe describe what's different about stage 2? And then we can think about why it might be having these effects.
Just the electrophysiology is a little bit different. That's a stage that is more stable than N1, that occupies 50% of an entire night. That's considered as light sleep, but still bona fide sleep. In most research, we think that sleep truly starts in N2, and there is a controversy about whether N1 is sleep, wake, or a mixture of two, or twilight zone or something. I would say N2 is the beginning of real sleep. I disagree with the complete loss of consciousness in N2 sleep. I think it depends on the people, and even in the subjective perception, you can wake people after like a few minutes, even hours of N2, and people still say that they are awake. So they must perceive something. And in our own studies, we see that they could respond sometimes to external stimuli during N2 sleep. So I'm not sure you lose consciousness.
But then you can also maybe respond to external stimuli in REM sleep as well, if it's something like a smiling task or a frowning task. So like the loss of consciousness being defined by an inability to process external stimuli is already confusing. But totally, there's sleep state misperception in N2 where people say they're still awake is there. And then if we are interested in dreams and creativity, your N2 dreams are often not as bizarre, as rich, as clearly influenced by the daytime as the hypnagogic dreams. And so just from what we've been saying about the possibility that the cognitive contents of N1 are useful for creative processing because of their kind of influence by daytime processing in addition to their bizarreness, I think both of those will go down when we get into N2.
We should acknowledge that there's some fundamental things that we must have wrong about this whole conceptualization we have. Back in the early 2000s, I did this study that showed on a visual discrimination task that you needed at least 6 hours of sleep in a night in order to show a subsequent enhancement in performance. And in fact, the more sleep you had in excess of 6 hours, the more improvement you showed. And then my student Sarah Mednick comes along and does a nap study and shows that a 90-minute nap gives you as much improvement as an 8-hour night. And that makes no sense to me at all, because we know that a 6-hour night gives you no improvement. And it's that same thing that a little bit of N1 gives you this creativity after you wake up. But if you get into N2, it's gone. But if you let it go for the whole night, it's back. So I think we've just got some conceptualization of what's going on here wrong. And I don't know what it is. But it's why we have all these things that on some level don't make sense. And I think the N2 after N1 is a perfect example of that. I think we have a conceptual gap and we don't know what to fill it with.
Which is part of what makes this such an exciting research area, right? So plenty of space for us to do studies. Let's move on from N2 now and talk a bit about the Dormio glove. Adam, you've explained to us already why you felt that stage 1 sleep and the dreams in stage 1 sleep might have been important for creativity. So can you tell us about how you decided to harness that and the device that you built?
A lot of the studies that I was excited about at the beginning of grad school were talking about sleep and dreams, but were secretly actually studies about N1, but they just didn't want to talk about it because people would say, that's not sleep, those aren't dreams. And so a big one is the Horowitz study, which was showing you could look while somebody was dreaming at their brain activity and then predict what their dream report was going to be by reading out their dreams in real time. And I was in grad school and I said, that's magic. And then I looked a little deeper, and it was N1 sleep. And then I took class with Ed Pace-Schott, and I took class with Bob, and people said, that's not sleep. And I said, this is a funky little weird period of time, and it seems like everyone's disagreeing, and I should probably learn about that. And so I got excited about N1 and sleep onset in particular because there were these big papers and this big area of misunderstanding. Then I just tried in a school project. I said, well, it seems like it's not that easy to make people play 6 hours of Tetris a day, and I don't want to sit around for that. So what if instead of doing something while they're awake for a long time, I just waited until they were asleep, if we're calling N1 sleep, and then I did the thing to them, whatever the thing is, Tetris sounds or smells or whatever, and see if that gets into their sleep, just to kind of condense the incubation process. If before the incubation process had been something like pre-sleep film exposure or a lot of gameplay or making all your students go on a hike, instead it was letting people fall asleep and playing something which was associated with a task or playing something which was associated with a memory, like a sound, and seeing if that would enter their dreams. And that was the idea. And I remember I did it with somebody who was in my class and didn't tell them much about what was going to happen. And I was like, I'll make them dream about chess. And they're falling asleep. They're in N1, drowsy, sleep, drunkenness, somewhere in between. I play a sound that I've associated with a picture before they fall asleep. That picture's of a chessboard. And then wake them up a little bit and say, what are you dreaming about? I get a few words, then they go back under. I play the same sound. I wake them up a little bit. I say, what are you dreaming about? I do this 5 times for an hour. And the person woke up and drew a picture of this tiger dripping off this drooping chessboard, which is basically a Salvador Dali painting. And I said, is that a Salvador Dali imitation? They said, no, I don't know. What do you mean? And I said, oh, whoa, this is so cool because Salvador Dali found this specific kind of visual changes in his hypnagogia, which inspired this art movement. And so I said, maybe Salvador Dali is not a genius. This period of sleep is a genius, and got really excited about that. And this idea that there's kind of a hidden, incredible artist in everyone that they could just find if they were playing with their sleep and dreams in the right way. And so the Dormio glove basically just automated that process. It used some biomarkers, some simple ones, not in the brain, but in the body, because your body changes at sleep onset also, to get at that N1 period. Whisper something, let them fall asleep. When they're in N2, wake them up right at that border, right at Horror Stage 9 or at the first 30-second epic of N2. What are you dreaming about? And then do the process over and over again for some set period of times. And then after the hour, they've had 5 awakenings, hopefully with some percentage of incubated dreams. And suddenly we can do an experiment. And it says, what if on purpose, I make this group of people dream of this thing, and I leave that group of people alone, and then I look at the difference after sleep in their cognition or their task performance.
Fantastic. And so you built this device, the Dormio glove, that can do that. And I know you have a couple of papers published already where you used it. The first one, I think, just shows that it works and that you can get them to have more dreams this way, and you can measure it. The second one, you had a series of creativity tasks, and from memory, you were looking at how prompting them in this way to dream, and you were specifically asking them to dream about trees, weren't you? Prompting them to dream about trees interacted with any benefit of the N1 sleep for the creativity tasks. Can you tell us a little bit about that study?
Totally, yeah. I'll tell you about that study, and then also just at the same time, because I wanted this to be useful in the real world, I was handing it off to artists who were using it in different ways and telling me about it. And there was a group of painters in Cambridge who were using it. And there was a musician in London who was using the glove. And so difference in results. I think maybe some people care about a scientific paper, and some people say, science has such a limited scope on something as big as creativity. If you just give an artist a tool, do they say that it helps them? And so both of those things were kind of part of the exploration. But the study, it takes these 3 tasks, the verb generation task and a creative storytelling task and alternative uses task, but all of them are different kinds of creativity. One is like, how widely does your mind wander around a topic? The other is, how creative is a story that you tell about a topic, according to computational measures of creativity and a panel of experts. And then the other one is, I give you an object, tell me all the bizarre ways you could think of using it in a certain period of time. And then we'll look at how useful and original and fluent those kind of generated uses are. And the sort of simple version of the study is you have some people in a group where you incubate dreams of trees, and about 9 out of 10 of them will report 1 dream of a tree if they each have a period of these 4 or 5 awakenings over an hour. About 67% of the total dreams will involve a reference to a tree. Then you have a group, you leave them alone, they sleep the same amount of time. Then you have a group who's awake, you prompt them to think about the tree at the same time as you prompted the sleeping people to think about a tree. Then you have a group who's awake and you leave them alone. And like Celia said, we see a benefit to creativity of just being in N1, but then we see an added benefit in interaction if somebody is in N1 and has a dream about a tree. And then a cool thing is we show later that there's this regressive relationship, that there's a relationship between how many dreams of a tree you have and how much of a creative performance boost you have when we group all our creativity tasks into one kind of super measure of creativity on our test. And so the zoomed out takeaway is this idea that maybe it's not just the sleep stage. Yes, the sleep stage is magic, but maybe it's the dream content, and that the kind of anecdotal evidence we have in addition to the like experimental evidence that we have from folks like Deirdre Barrett, that maybe it's really a good idea to try to write down what you're thinking about by the side of your bed and wake yourself up a few times and see if you can boost your creativity that way.
I find it a really exciting study myself. My understanding is the more that they dreamt of trees as a result of the prompts, the greater the creativity benefit of the N1 sleep. But the question that I've always had about this study is, if they're always dreaming about trees, but the creativity tasks were nothing to do with trees, why should those dreams of trees actually impact upon the creativity task?
I always forget to say this. All the creativity tasks are about trees. You're telling a creative story about a tree. You're thinking of alternative uses for a tree. You're doing the quickest verb-noun associations you can around tree. It's all around trees.
Okay, this answers a lot of questions, and I have to say that we were wondering whether it was a kind of a general effect of the fact that you are dreaming, irrespective of the content of the dreams, but this clarifies a lot. The problems are about trees as well.
Yeah, and the second thing is it's a poorly controlled experiment in the sense that, in a way, you have a group who's dreaming about something specific, you have a group who has no incubated dream, but what someone should do as a follow-up is if you have a tree-related task and you incubate dreams of trees in some people and then dreams of elephants in the other people, and then you see a difference, then you know that it's not just kind of the poking them towards something specific that makes them more creative. There is a link thematically between dream content and post-sleep creative performance because the creative tasks are about trees. There is not an active control in the sense of a dream of an elephant.
So we don't know if asking people to pay attention about a topic as they're falling asleep and then dreaming about them makes them generally more creative or only more creative about that topic. That study hasn't been done. It brings me back to this question I've had about the thoughts we normally have before we fall asleep. And the thoughts everybody has as they're in the process of falling asleep tend to be about unfinished business from the day before. No one lies in bed and tries, as they're falling asleep, finds themselves remembering phone numbers, right? It's all about issues of concern. And my concept is that the sleep onset period has evolved basically to let us line up and tag those memories from the day that are important and need further processing during sleep. And Celia, you're almost taking that pre-sleep and rolling it into N1 and saying that, N1 is taking these completely or partially formed memories from the day and deciding, okay, these are the ones I'm going to work on keeping, and these other ones I'm just going to let them go.
I think, again, in keeping with some of the themes of the podcast, you can focus a little more maybe on mechanisms and electrophysiology, or maybe a little bit more on dream experience and phenomenology. I was excited about some of these people come in and they have an incubated dream and they wake up and they say, wait, so like I could always choose my sleep onset dreams? And I say, I don't really know. I've only tried this with the people a day at a time, but you can certainly try. And that feeling of control itself seemed really powerful in the sense of agency or self-efficacy around your dream content. And so I met a guy named Wes Youngren, who's really interesting sleep researcher, really focused on nightmares, former Marine himself, so really focused on nightmares in folks who have been in the military and have perhaps trauma-related dreams. And we have a paper coming out in Sleep Advances, which shows that, yes, you can incubate dreams in folks. And afterwards, a day later, a week later, you can increase their feelings of self-efficacy, how in control they are of their dream life. And so Wes is working with a population who have moderate or severe nightmare disorders and has a new paper showing that you can do the same process, targeted dream incubation, and that you can lower suicidality, increase joy, and increase self-efficacy just by giving people a concrete experience of control. And this is sort of couched within the larger literature of imagery rehearsal therapy, which for listeners is a kind of re-scripting of your nightmares that people can do in the context of repetitive or challenging traumatic nightmares. But one of the big predictors of treatment efficacy and of dropout rates is if people do or don't get to have a concrete experience of control early on. Just because feeling like, it might work, I really believe I could re-script my nightmares. It makes sense that it increases motivation.
And how do you give them a concrete experience of control?
Well, I mean, if you're in the context of imagery rehearsal therapy, hopefully early on, one of the rescripting elements works, a small one, we change the attacker's color from black to pink, whatever it is. But the idea here was, I'm not even going to mess with overnight sleep. We're going to bring them in for a nap, and we're going to choose a topic, and they're hopefully going to have a successfully incubated dream just in hypnagogia, because it's a lot easier than rescripting a nightmare, and that concrete experience of control will make them feel more self-efficacy around dreams in general as they head into the imagery rehearsal therapy.
So if you tell them as they're lying down for a nap, think about a tree, and then they fall asleep and you wake them up and they say, oh my God, I was dreaming about a tree. I just controlled the content of my dream. And then that generalizes for them very quickly into, I can probably control the content of my dream whenever I want.
Well, that sounds amazing if you can give people that sense just by getting them to control some small element in that way. So sadly we're almost out of time, but given that you're all extremely creative people and you're all doing lots of interesting creative things, I have one final question for you all, which is, do you use these techniques yourself in your own life and in your own work?
Yeah, for me, all my career is based on insight into the N1 period, but I don't use the Edison's method, for example, because I don't need it. I'm kind of aware of my sleep onset imagery at night, and I rehearse the problem I want to solve, and then they take shapes, and that's really cool. And I think all of my scientific ideas come from this phase. So
do you wake yourself up and write them down, or do you just kind of pay attention and make a mental note?
Yeah, make a check, and then the evaluation phase will be better when I'm awake, and then I'm like saying, okay, that's a good start, and then the critical process starts. But originality of the idea, or the first hint of the directions, comes from N1, or for me, it's clear.
And you already told us, Celia, that you use this as a technique.
Yeah, but mostly for the sleep offset, because I'm not as conscious of my hypnagogia as Delphine said.
How about you, Bob?
Well, it's very funny. I tried basically just to do the think about a tree. And my thoughts, I can't keep it on trees. I'm thinking about trees, I'm thinking about trees, and I'm thinking about this work I have to get done, and I'm thinking about whether this process is working, and I'm thinking about how long have I been, so I think that by the time I fall asleep, I'm not thinking about trees anymore. Now, I haven't set an alarm to wake me up 5 minutes later to see whether I will nonetheless be dreaming about trees. But I have found it so far impossible to keep a chosen topic in my mind all the way to sleep onset.
I do it all the time, and mostly for fun. I have really intense sensory motor experiences in sleep onset, and I have the abnormal thoughts, and I have the iTunes visualizer also that some people talk about, the screensaver. But if I'm at the right period of sleep onset, like right where my body is starting to feel a little bit lighter, I can say something like riding on the back of a humpback whale, and it's like such a physical experience, but it's so nice. It's a little bit distant, a little bit like watching the movie of my dream, but feeling it in my body at the same time. It's such a weird, fractured psychological state. It's pretty hard to describe. I play around a lot in sleep onset. And during my thesis, like Celia, I was totally using it for dissertation writing. And now I'm mostly just, riding whales or having fun.
And I think that's probably a great place for us to wrap up. But yeah, it's great hearing about your personal experiences of this as well as your science. And I think I'm going to have to try it because I've never tried any of these techniques. So you've motivated me now. Thank you all very much for this wonderful discussion and for all of your inputs. Yeah, it's been great.
Thanks for bringing us together.
You've been listening to the Sleep Science Podcast with me, Penny Lewis. Our guests today were Professor Bob Stickgold, Dr. Adam Horowitz, Dr. Delphine Oudiette, and Dr. Celia Lacaux. This was a special episode about stage 1 sleep and how it's thought to boost creativity. In the next episode, we'll tackle the question of how sleep changes across the lifespan. From all of us here at the NAPS Lab in Cardiff, thanks for listening and sweet dreams.